So we're going to discuss the annuities formula when the present value is equal to 0. So we only use this formula when our present value is equal to 0. Then we have our future value is equal to our payments per period. So if it was monthly, quarterly, daily, etc. Your K is your duration. And it's the duration in the units of the payment periods. So if the payment periods were in months, then the duration units need to be in months. Then we're going to have our effective interest. And here, once again, it's our effective interest per payment period. And this is very, very important. So I'm going to highlight it here. So the duration of the payments, the payment period, the duration, and the effective interest units need to coincide. That often means that you will have to work out the equivalent effective interest to get the IM that's required for this formula. Because you'll often get the nominal interest, and the nominal interest has compounding periods. And if the compounding periods don't coincide with the payment periods, you will have to get the effective interest that you got from a nominal interest and then convert it using the equivalent effective interest formula to get the effective interest here. Okay. So here we have an example, which is invest 2,500 Rand per quarter for the next 5 years at an interest rate of 9% per annum compounded quarterly. And it asks us, what is the value of the investments after the 5 years? So in order to use our formulas, we have to see whether our present value is equal to 0 or our future value is equal to 0, because that dictates which formula we use for these annuities. So in this question, it is asking us what is the value of the investment after the 5 years. So we have a future value which is unknown. And nowhere in this question does it say we put down an initial present value amount. In fact, it goes straight to invest 2,500 Rand per quarter. So we have the present value, in this case, is equal to 0. And we're going to have a future value amount. That tells us that the formula we're going to use is the future value is equal to the payments, 1 plus IM, brackets to the power of K, minus 1 divided by IM, and all of this is multiplied by those payments. So that's the formula that we're going to use. Next, we're going to just write down everything that we know so that we can then go through the conversions to make it what we need for the formula. So we're going to start off with the fact that we're investing 2,500 Rand per quarter. So we have the payments is 2,500. And we have that it's per quarter. So we're just going to write per quarter here. And that's going to be very, very important, because remember, the effective interest rate and the duration need to coincide with the payment periods. So we're going to have to make sure all the units coincide with that. So this per quarter is going to be super important. Okay, next up, it's for the next 5 years. So we have K is equal to 5 years, but we need it in quarters. So we're going to convert it by multiplying it by 4 to get us 20 quarters. Okay, then we're going to continue on, and it's at an interest rate of 9% per annum compounded quarterly. So we have J is equal to the nominal interest, 9% per annum compounded quarterly. And we know it's a nominal interest because it's a per annum interest with compounding in brackets to indicate what the compounding is. Now, we will be needing I4 because the M there is actually the per payment unit. So we need the effective interest rate connected to the payment unit. So our payment unit is quarters. So we need I4. This is useful to us because one, we know that J is equal to, and it's IM times by M, where this M is the compounding period. So if it was compounded monthly, you put the months there, yearly and so on. So just a note, just be very careful that the M in this formula here that I just spoke about is not the same M that features there. It just so happens that they coincide in this example. But when we're looking at the nominal interest rate formula, it is the effective interest rate per compounding period times by the number of compounding periods in a year. In this case, the compounding periods and the payment periods coincide. Go look at the example with the annuities and PV is equal to 0 to see where it doesn't coincide and the steps that we'd have to take. In other words, we would have to do an additional step where we work out the equivalent effective interest rate. Okay, so back to this problem, we're going to get II4, which is equal to J divided by 4. But it's J, which is in decimal fraction notation, so it's 0.09. That's just the 9 divided by 100, divided by 4. And we're just going to get into a habit of saving this on our calculator instead of having to input it all at once. So we would actually store this value. We'd work it out and store it in a variable so that we don't have to put in our longer formula 0.09 divided by 4. Why do we do that? Because we want to limit the rounding off errors that we create. So we want to bring the entire answer through to our second formula. Okay, so now we're going to put it into the formula so we can solve it. We have the payments is equal to 2,500. Big brackets, we have 1 plus. We're going to just recall our value and just going to get into the habit of doing that so that we don't make mistakes. Or alternatively, you can put it in there and type it in there. To the power of 20 minus 1 divided by the recall A. And that's going to give us an approximately equal to. Why approximately equal to? Because I'm rounding off to 2 decimal places. So that's going to be 62,278.80. And before we go and do this on our just a standard scientific calculator, so you can just see how to input this. The I4 is 0.0225. So just so that you're aware, like when you're doing the step processes to make sure you know where your errors are, your I4 is going to be 0.0225. You will store it. Alternatively, you would type in the 0.09 divided by 4 in here. And you do that just to get into the habit of not rounding off your values. So in this case, it's not a huge deal, but you do want to get into the habit of not rounding off your values too early. So you want to bring the entire value across. So get into that, process where you always use your memory features of your calculator to your advantage for this. So the first thing you're going to do is going to work out I4, which is just your nominal interest rate divided by 4. So we're going to say 0.09 divided by 4 is equal to, and we're going to store it. So we're going to say shift STO and A to store it into variable A so we can use it in our next formula. Now we're just going to clear our screen and we're just going to type in our next formula, which is the payments, which is 2,500. And then it is going to be brackets, 1 and brackets again, 1 plus, recall A, close brackets, the power of 20. We're going to make sure that we go down the line there, minus 1, close brackets, divided by, and recall A. And now once again, we're just going to make sure that we're at the end and say equals. And there we have our answer is 62278.80008. And obviously we round off to 2 decimal places, so it's just the 0.80. 20